Hola, my pre-algebra amigos. I hope you're ready for some fun and adventure, because we're just about to have it. I do want to tell you that, as I mentioned in your sheet that I sent home with you, unfortunately we're not going to continue along the lines of statistics and probability in chapter 10 that I had planned. And I do want you to know the reason for that is that it's just hard to communicate over a good span of distance, and so I didn't want to make this chapter, or whatever chapter we'd be doing in this setting for these couple of weeks, any more difficult than what it's going to be anyway as far as just challenges goes. It's not going to be easy, guys, but it's not going to be impossible either. I do want to encourage you, as I've said in your other classes, I don't know if you've seen those videos yet or if you're watching this one first, but make sure you take really good notes, because I did write that on your syllabus that I sent home, that you're going to be able to use your notes that you take for math for your test. And I don't normally let you do that, but I understand that in these more than challenging circumstances that I think that's plenty fair to allow you guys to do that. I'm going to have our problems on the board. I'm going to go through them. There will be intervals that I'll slice the video. You might, well, you're going to notice it, but you're not going to have to wait for me to rewrite everything. I'm going to rewrite everything, and then edit, and it'll come right in, so it doesn't waste your time. But anyway, we're going to get right to it, and what we're doing, guys, is chapter 11 instead of chapter 10. We're just going to skip ahead, and we're going to do chapter 11, in which we are going to be dealing with radicals. I'm going to get out of the way so you're going to be able to see the board. And dealing with radicals, which largely is going to be squares and square roots. I've had you guys ask a curiosity, which I love. I think it's a really cool thing. You wanted to know some more about square roots. Well, remember, a square root, and for symmetry purposes, I like balance, don't you? I have put, for symmetry purposes, the square root symbol on both sides, and as you'll see, there will be a number that's underneath a square root. Again, you guys have asked, well, what is a square root? And even though you've seen it before, we really haven't just thoroughly defined it yet, because we haven't had a section on it. But that's going to change right now. And what I haven't read, and make sure, guys, you're taking notes on this, because if you take notes and you use them, you will do just fine. Every single one of you. You will do well if you take notes and you use those on your work. I will let you know ahead of time, as I sometimes do, though, that this is one of those not so easy chapters, because there are all brand new concepts in it. And if you don't take good notes and you don't use them, you're probably not going to do very well, and you very well might not pass this chapter. Normally I have one student, I believe, if I'm not mistaken, who always takes notes, and that's Mr. Ken. Hi, Mr. Ken. Thank you for taking good notes. But guys, all the rest of you, including those of you who are really sharp and say, I don't have to take notes, you might need to on this, or you might really struggle on this chapter. New concepts, difficult, challenging, but not impossible, and not things that we would fail to overcome. You guys will do well if you put the effort in, and I have confidence in you to do that. Well, I have written in red at the top of the board, as I often do, some pretty important information that's going to be very significant not only for this lesson, but the entire chapter. What is a square root, you guys have asked? Well, in terms of words themselves, a square root is a number, okay? And technically it can be a letter, and we might just say a term, but let's just keep it simple for now. A square root is a term, and for our purposes at the moment, it is a number whose product, which means something that is multiplied by something else. So a number whose product, when multiplied by itself, is itself. A number whose product, when multiplied by itself, is itself. I have a suspicion what you might be tempted to do right now. Wake up! Don't do that. No, pay attention. Did I startle you, Kelsey? Joe, you still there, buddy? Love you guys. No, don't sleep on me through this, okay? I need you to pay attention. Let's put numbers to it so it'll make more sense. The square root of a number is whenever you take some product of that number, you multiply that product by itself to get what was under that square root symbol. For instance, if I'm trying to find the square root of 1, By what product of 1 could I multiply itself to get me 1? What's the square root of 1? Well, what is some product of 1 that when multiplied by itself gives me 1? Guys, what's 1 times 1? 1. And therefore, the square root of 1, this is kind of an oddity. They're not all going to be like this. The square root of 1 is 1. That still might not make as much sense, but I guarantee you it will. If you're staying with me and you're focusing, it will on this second one. What's the square root of 4? In other words, what is a product of 4 that when multiplied by itself gets me 4? Well, outside of 1 and 4, there's only one product of 4, and that's the number 2. And guys, what is 2 times 2, or 2 squared? It is 4. And therefore, the square root of 4 is 2, because 2 is a factor of 4 that when multiplied by itself, 2 times 2, gets me right back to 4. And some, I don't want to confuse you, but just as far as a piece of information, some say it this way, that a square root is the inverse or the opposite operation of squaring a number. And I would say that that's entirely correct. Maybe above our pay grade for right now. But that is one way of looking at it. The square root is the inverse or the opposite of the squaring of a number. Kind of like addition and subtraction are opposites. Kind of like multiplication and division are opposites. The square root is the opposite of squaring a number. All right, how about this one? What is the square root of 9? In other words, what factor of 9 could I multiply by itself to get me 9? That would be the number 3. What is 3 times 3? It is 9. And so the square root of 9 is 3. How about the number 16? What is the square root of 16? What factor of 16 multiplied by itself gets me to 16? It can't be 1 and 16 because they're not the same. It can't be 2 and 8 because they're not the same. It can, however, be the number 4. Because 4 times 4, 4 times itself, or 4 squared, gets me to 16. And so the square root of 16 is 4. Now, I know these kind of look like division symbols, but they are not division symbols. They are square roots, and there's a difference. A division symbol doesn't have that little loop on it. But you have the curve or the V on the left side of the square root. Those are different. How about the square root of 25? In other words, what times itself gets me to 25? It is the number 5. Because 5 times 5, or 5 times itself, 5 squared, is 25. All right, we could go on to eternity with this. Don't worry, we're not going to. I just want to give several examples leading in that would help us. We'll do one more. What's the square root, guys, of 36? In other words, what number times itself gets me to 36? All right, I could have 12 times 3, but that's not the same number. I could have 18 times 2, but that's not the same number. I could have 1 times 36, but that's not the same number. However, the number 6, I can square or multiply 6 times 6, and guess what I would have? 36. And so these are the square roots, and if you'll notice, 1, 2, 3, 4, 5, 6, we're counting up in square roots. I do want to direct your attention in your book, open it if you haven't already, but in your book, page 451, the top right of that page, actually it's top left of that page, but the top left of the page, is the very top of it, it has a whole list of what all the squares are, 1 through 20. It suggests memorizing those. Well, I'd agree that would be handy. I would suggest at least do through 12. All right, because that's just the common multiplication table you ought to already have memorized anyway. But at least do what 1 times 1, 2 times 2, 3 times 3, etc. through 12 times 12. Have memorized what all those are, common multiplication table, because it'll be really helpful in this kind of stuff. I direct your attention to the top of page 451 because I will let you copy down that square help that's almost a chart. You can put that in your notes, even though I don't have it on the board. You're welcome to put from the book whatever that you want in your notes. And when you take your test, you can use your notes. Now on the test, I don't let you use your book. As always, you can use your notes and your book on your quote-unquote quizzes, which are nothing more than your homework. Okay, no big deal there. But on your test itself, I'm being very kind in our challenging circumstances to let you use your notes on your test, but you can't use your book. But feel free to copy things like this nice chart on page 451 out of your book that'll really help you with these kinds of things. Okay, let's move on more so now with the introductory info covered into our lesson proper. I want you guys to help me out. I wish I could call on you. I wish I could say, Gage, what's it? Okay, that kind of thing. I'd like to do that. Number one, what is the square root of 81? In other words, all I'm asking is, and all the book is asking you to do to master these concepts, is to ask yourself what times itself gets you to the number of 81. What number times itself? Well, this is multiplication table, guys. What's really interesting is if I take the number 9 and I do 9 times 9, what do I get? 81. Therefore, the square root of 81 is 9 because 9 times 9 gives me 81. Does that make sense? I hope it's connecting. I think it should. And if not fully, I have no doubt that there's progression that is taking place. Now, number 2 is a little bit different. We've done all these square roots that are just like number 1. Number 2 is a little bit different because there's a negative that is sitting outside of that square root symbol. And here is what I do with that. For right now, I just kind of ignore that negative and I say, what's the square root of 81? Well, I've already done that. The square root of 81 is 9 because 9 times itself, or 9 squared, or if you prefer, 9 times 9, is 9. So the square root of 81 is 9. But look, I have a negative outside of that square root. It's order of operations here. And whenever you have a negative outside of parentheses to distribute, you just attach whatever's on the outside through the process of multiplication to whatever's on the inside. And that's what you're doing right here as well. You're just going to, after you simplify what's on the inside, again, order of operations, then to fully simplify, you're going to attach what's on the outside of the square root, just like a parentheses, to what's on the inside, simplified. And so all I'm going to do is move that negative to the number that's been simplified. And so my answer, it slants a little bit, but my answer is going to be negative 9. And if you're curious and you care, the mathematical process involved, remember if there's just a negative sitting outside there, there's an understood imaginary 1. And so it's like multiplying whatever's simplified on the inside by negative 1. And that's really the mathematical explanation behind it, if you care. That's not really important just with a negative sign now, but later, even in this lesson, we're going to have like a number sitting on the outside. And what that means is I multiply, once this is simplified on the inside, order of operations, then I'm going to multiply what's on the outside toward what was simplified on the inside. So I do want to give you a heads up about that. Now, what about something like this, number 3? Would I just kind of ignore, this negative's underneath that square root sign, would I just kind of ignore that negative like I did there, simplify, and say, what times itself gets me to 14? That's what the square root is. What times itself gets me to 14? Well, that's the number 4, right? 4 times 4 is 16. And then do I just slap a negative on it and say, my answer is negative 4? You don't. And stay with me. This one is somewhat tricky, and here's why. If you have a negative sign under the square roots, that's an impossibility, and here's why. What times itself can get you to 16? Think about it. If you had negative 4 times itself, negative 4, do you have negative 16? No. A negative times a negative is a positive, so it's a positive 16. If I had just 16 underneath that square root symbol, what would get me to 16? 4 times 4, right? Okay. But I can't use negative 4 and get me to negative 16. 4 times 4 is positive 16. Negative 4 times negative 4 is a positive 16. And that's why if you have a negative underneath that square root sign, Guys, the answer is it is not real. That's your answer. Or if you want, you could draw what looks like a 0 or an O with a line through it. That means no solution. That's okay too. Not real or no solution. And the reason is there is no number when multiplied by itself is going to give you any negative number. Because if it starts as a positive, two positive numbers multiplied together are always going to be positive. If it starts as a negative, two negative numbers multiplied together are always going to be a positive. And that's why the number underneath that square root symbol always has to be a positive. Otherwise, don't go any further, because if it's a negative, it cannot be a real number. Now, that's not the same thing as if the negative's on the outside, meaning once you simplify a positive number, then you can multiply it by a negative number, which in number 4 is exactly what we've done up here on number 2. Now remember, if it helps you out any, that negative on the outside, technically there's a 1. We just don't write it because it's redundant. But it's like there's a negative 1 there, because there actually is, even though we just write it as a negative sign. But as long as the number under the square root is positive, I can go ahead and calculate that. So I have a positive 49, and I'm trying to find what the square root of that is before I deal with this negative that's on the outside, order of operations. What's the square root of 49? In other words, what number times itself as a factor of 49, what number times itself gets me 49? And the answer to that, guys, and what I need to memorize if I don't have it memorized already, and I can look at that chart at the top of page 451 if I need to for right now, that'll help me out. But 7 times 7 is 49. And so the square root of 49 is 7. But now look, I have a negative sign, or a negative 1, that's multiplied to whatever the value is on the inside when simplified. Guys, what's negative 1 times what's negative 1 times 7? It's negative 7. And so all I do is just write a negative in front. Okay. How about this one, number 5? If I'm trying to find the square root of the negative number 4, negative 4, what two numbers, or I should say what single number, when multiplied by itself, gives me a negative 4? Remember, if the negative is ever found underneath the square root symbol, don't work it any farther. Say it's not real. Or in other words, there is no solution to that problem. Because there is no number, positive or negative, when multiplied by itself that will give you a negative number. Because if it starts out as a positive, it has to end a positive. If it starts out as a negative, but it's multiplied by another negative, it's always going to turn into a positive. So if there's a negative number underneath the square root symbol, it is not a real expression. Not a real number, no solution. Let's move on to numero 6. And so we have negative, but notice it's not inside, it's outside. That's okay. We can deal with that. And what we do is understand, well, that's an imaginary 1 out there, a negative 1. We don't write it that way because it's redundant. But I just ignore that for right now and do order of operations. What's the square root of 64? In other words, what number times itself will get me 64? And the answer to that is, use the handy dandy chart on the top of page 451 if you need to. But 8 times 8 is, guess what? Or 8 squared, it is 64. And so the square root of 64 is 8. Then I multiply that by what's on the outside, negative 1. 8 times negative 1 is simply negative 8. And that's my answer. All right, how about number 7? I have a negative sign outside the square root symbol, but look, I have an issue, ruh-roh. I have a negative sign under the square root. And the first thing I want to do is see, is there a negative sign under the square root symbol? And if there is, what does that automatically tell me? Guys, number 7 is not a real number. In other words, it's a 0 with a line drawn through it. It is no solution because there's no number that you can multiply by itself to get you a negative number, regardless of whether it's a positive or negative when it starts. Now, number 8 is a little bit different though. I have negative outside the square root symbol, just like in 7, but unlike 7, there is no negative under the square root sign, and so that's okay. I can deal with that. So I'm just going to ignore this for right now. I understand there's an imaginary 1, okay, that precedes the negative sign. But for right now, I just ignore it. Order of operations, do what's inside of whatever's set off as far as brackets or parentheses, or in this case, square root symbol. Do what's found in it first. What number times itself will get me to the number 100? This is the largest one we've done so far, but there are much larger that we could do. How about 10? 10 times 10 equals what? 100. And therefore the square root of 100 is 10. But I have another step because there's a negative sign outside, which means whatever that square root of 100 is simplified, I multiply it by negative 1. Well, the square root of 100 simplified is 10. What is 10 times negative 1? All I do is just add a negative sign, because that makes it a positive times a negative, makes it a negative number. So the answer is negative 10. All right, how are we doing so far? You guys doing all right? I hope so. Like I said, I have confidence in you. Stay with me. I'm not done. I do have to cut out and splice. Again, I think I mentioned at the start of the video, you're not going to see me do that, but I'm going to put some more problems up. We're going to work just through a few more, and that'll be it for the day. A square root is a number whose product, when multiplied by itself, is itself. No, I'm not reteaching what I did just a moment ago, but what I'm saying is a number when squared comes out to a nice, even, round number. That's what's called a perfect square. In a perfect world, everything, including numbers, would be perfectly round, easy numbers. Unfortunately, we don't live in a perfect world, and you already know that. But we can use what we know about perfect squares to find out more information about numbers that are not perfect squares. And we're going to do that for numbers 9 and 10. Number 9, between what two numbers does the square root of 32 lie? Well, I can use what I know about perfect squares to nestle into a nice little niche, at least an area where the square root of 32 in value must be found. And let me give you an example. I know that the square root of 25 is a perfect square. And the reason for that is 5 times 5 gives me 25. Okay? I also know that the square root of 36 has a perfect square because 6 times 6 gives me 36. So in other words, the square root of 25 simplified is 5 because 5 times 5 gets me 25. The square root of 36 is 6, and the reason for that is 6 times 6 gets me to 36. Now I want you to notice something right here. Where would the square root of 32 be in relation to these two perfect squares? Can't be on this side, can't be on that side, because 32 is larger than 25, yet it's smaller than 36. It has to be found between the two. And so between what two numbers does the square root of 32 lie? It lies between these two numbers, 5 and 6. And so I've answered what's being asked in number 9. Number 10 takes that to another level. It says, estimate the square root of 47 and do so to the nearest tenth. Now I know it's not going to be a perfectly square number when simplified, and here's why I know that. I know that the square root of 36 is 6, because 6 times 6 is 36. I know that the square root of 49 is the number 7. And the reason I know that is that 7 times 7 gets me to 49. And what I notice about the number 47 is that while it's larger than 36, it is smaller than 49. And so the square root of 47 has to fall between those two. Now what I want to do again is take it a step further than what I did in number 9. I look at this and I see that 47 is much closer to 49 than what 47 is to 36. And so I'm going to present a couple of possibilities. I know that it has to be greater than 6, but less than 7. And so that number is going to be 6 point something. And I'm just going to give a couple of options in my... All it is an estimation, guys. You can't be wrong in an estimation as long as it's reasonable. And a reasonable estimation is it's going to be 6 point something high, really close to 7, because 47 is so much closer to 49 than what 47 is to 36. And so I'm going to guess maybe 6.8 and maybe 6.9 when rounding to the nearest tenth, which, don't forget, common simple math, little baby elementary school math a while back is just, as we like to remind, is just the first decimal place. Guys, I'm going to let you do this on this one. Pull out your calculators and punch in what is 6.8, and you might not see this on my calculator, but that's what I'm doing. What is 6.8 times 6.8? And 6.8 times 6.8, can you see that okay, is 46.24. Okay? If I square that, it's 46.24. Alright? Now that's 6.8 squared. If I square 6.9, I come up with this. And watch, all I'm doing is just taking 6.9 times 6.9 equals 47.61. Now, 6.9 squared is only 0.61 away from my original number, 47. Whereas 6.8 squared, that's 46.24, which is 76, if my mental calculations here correct, 0.76 away from 47. Both are close, but look, 6.9 squared is just a little bit closer. So if I were to simplify the square root of 47 on the basis of my estimations and using the handy mechanical calculator that God's given me, sometimes that's more helpful than the mental one, a little faster, then my estimation is going to be 6.9, much closer to the square root of 49, which is 7, than the square root of 36, which is 6. Now that one may be a little bit more confusing compared to the others. Don't worry too much about it, guys. I want to tell you really quickly, you're actually doing what Algebra 1 is going to be doing next chapter. And so if you find it kind of tough, don't get down in the dumps. We'll work through this. We'll do so at a reasonable pace. As you have questions, don't forget to text, email, Facebook message me, do our chat on our class thread if you're using your parents' Facebook account. Email me, whatever is easiest for you guys. We'll work through it together. Just stay with me and don't give up. I'm not real concerned about these. You're going to have like 1 or 2 questions that you're going to have to answer on the estimations. And if you're a tenth or 2/10 off, I'm probably not going to count it against you anyway. But it does need to be a reasonable answer and closer to 1 as compared to the other on the basis of the numbers. Now in 11 and 12, guys, these are much easier than what we just did. So let's finish strong here. We have the square root of 64 in 11a plus the square root of 25. Now, these are separated, and so I need to consider them separately. First of all, what's the square root of 64? Or what times itself gets me to 64? That's the number 8, because 8 times 8 equals 64. So I've simplified the first one, plus, keep your signs, what is the square root of 25? Or what times itself gets you 25? That is 5, because 5 times 5 is 25. And so the square root of 64 simplified is 8. The square root of 25 simplified is 5. And now, guys, all I do is the most babyish of all math. What is 8 plus 5? And don't tell me 12, please. Love you guys. 8 plus 5 is, I know you, I love you, but I know you. 8 plus 5 is 13. You know me too though, so that's alright. 8 plus 5 is 13. That's it. Just simplify the two and just do the operation mathematically that's given. Just add the two together. 8 plus 5 is 13. 11b is a little bit different. When you have everything all under one beautiful square root umbrella, you simplify, just like within parentheses. Under square root, you do the mathematical operation if they're under the same square root before you take the square root. And so all I have here is 72 minus 23. And I'm just going to stack those on top of each other. Alright? And so I need to borrow, which really is more theft. We'll talk about it another time. But I need to turn that 2 into a 12, which makes me turn my 7 into a 6. What's 12 minus 3? 12 minus 3, don't say 8, is 9. And 6 minus 2 is 4. Now, remember though, that's all underneath a square root. So you're not done when you've done that subtraction. You've just simplified what's underneath that square root. Now I can ask myself, what is the square root of this single number? And guys, the square root of 49 is what multiplied by itself gives you 49. Think about it just a second. 7. Because 7 times 7 is 49. So the square root of 49 simplified, once we've done our subtraction, is 7. Okay, let's do it one more and we'll call it quits. How does that sound? Now remember, like the negative sign, if it's found outside, I said you could have a number, and really we had a number like -1, it's just the one's invisible. Well, here we have a number that's not so invisible. That's multiplication, but it has to be done at the end, order of operations first, after we take care of what's set off in parentheses, brackets, or in this case, underneath the square root symbol. I'm going to keep my -4 and do that last, but I need to simplify the subtraction that's all under one big, beautiful square root umbrella. And to do that, I just line up in subtraction right over here. Guys, what is 1/16 minus 35? Well, 6 minus 5 is 1. Alright, I need to borrow, or steal, if you prefer. Make that 1 and 11, and to do that I have to make my 1 a 0. And now what's 11 minus 3? 11 minus 3 is, of course, 81. I'm not done. All I did was simplify what's under the square root. Now look, I still have to simplify what's under the square root before I can multiply it to that -4. So I'm going to carry it down. And guys, what is the square root of 81? In other words, what times itself gives you the large numerical value of 81? That is the number 9. Okay? 9 times 9 equals 81. That's why the square root of 81 is 9. But that's going to be multiplied by -4, and that's why I've put that in parentheses. Whatever you have on the outside of that square root is just like if it were parentheses, and that's why at the end I've just made it parentheses when I've simplified, because it's the same concept. Whatever's on the outside, you're going to multiply that to whatever's on the inside. And so to find my answer, I ask myself, what is -4 times 9? Well, 4 times 9 is not 32, but it is 36. But look, I had a negative number times a positive, so what kind of 36 do I have? A negative 36. And that's my answer. Now remember, you can look back, the good thing about this with videos, you can view them several times. If you need to, you might not want to, but if you need to, guys, spend the time to do that. They're going to be a little shorter than what our class periods are. You don't have the time of getting ready and driving to school and back, so spend a little bit of extra time, and what you're going to need to, contact me in any and every way you want to, guys. I am here to help you thoroughly all the way to the end. Look at me. I'm not against you. I'm on your side. And I know you know that, but I just want you to hear it to make sure you doubly know that to be the case. All right, I love you guys. I'm proud of you. Keep up the good work, and I will see you tomorrow for your next math lesson.